All right, let's dive into something that's so fundamental, it literally makes up everything you see, everything you touch, everything you are. We're talking about the states of matter. But we're not just going to list them off like in a textbook. No, we're going to climb them step by step up what I like to call the energy ladder. And as you'll see, every single step is powered by one thing: energy. So let me ask you a question to get started. What do a solid block of ice, the air you're breathing right now, and the sun, what could they possibly have in common? I mean, they seem like total opposites, right? But here's the secret. They're all made of the exact same fundamental stuff, just in different states of being. And that stuff, of course, is what we call matter. The official definition is pretty simple. It's anything that has mass and takes up space. But here's the key, the real light bulb moment. What separates a solid from a liquid, or a liquid from a gas, isn't the substance itself. It's all about how much energy its tiny little particles are packing. This is the whole foundation of our energy ladder. So let's begin our climb. We're starting right at the bottom on the very first rung. We're at the solid foundation, which is the state of matter where particles have the absolute lowest amount of energy. You know solids. They're everywhere. The ice in your drink, the wood of your desk, the metal and glass of the phone in your hand. They all feel firm, stable, right? And there's a very specific reason for that, and it all comes down to how their particles are behaving in the super low energy state. So what really makes a solid a solid? Well, it has a definite shape and a definite volume. A rock isn't just going to change its shape or size on its own. And the reason for that rigidity? Well, it lies deep inside, at the microscopic level. I want you to picture the particles in a solid, like a crowd of people packed shoulder to shoulder in a tiny room. There's just no space to move around. All they can really do is just vibrate, kind of jiggle in place. This tightly locked, vibrating structure is exactly what gives solids their fixed shape and volume. Okay, but what happens if we start to pump some energy into those vibrating particles? We're about to take our second step up the ladder, and we're going to unlock a whole new state of being. And this process, of course, is melting. When you add energy, usually in the form of heat, to a solid like ice, its particles start vibrating more and more violently. They shake so hard that they literally break free from that rigid structure, and they start to flow. And the result? A liquid. Now, it still has a definite volume. A liter of water is a liter of water, but it loses its definite shape. Now it flows, taking the form of whatever container you pour it into. That's because those particles now have just enough energy to slide past one another. They're still close, but they're not locked in place anymore. And we see liquids all the time. Water is the obvious one, sure, but also the milk in your cereal, the oil in a frying pan, the juice in your glass. They all flow and adapt because their particles are in this energized, mobile state. So, we've gone from particles that just vibrate to particles that can slide around. What's next? What happens when we climb to the next rung and we add even more energy? Well, the particles are getting ready to take flight. When you keep adding energy to a liquid, think about a pot of boiling water, you get evaporation. The particles start moving so incredibly fast that they completely break away from each other. They just escape the surface of the liquid and fly off into space. This brings us to the gas state, and this is where the rules totally change. A gas has no definite shape and no definite volume. Its particles are now super far apart, zipping around freely and randomly. This lets them expand to fill any container they're in, no matter how big it is. In fact, you're surrounded by gas right this very second. The air you're breathing is a mix of gases like oxygen and nitrogen. And another perfect example is the steam rising from a boiling kettle. That's just water in its super energized gaseous state. So we've climbed from solid to liquid to gas. You might think we're done, right? But believe it or not, we have not reached the top of the ladder yet. There is one final step, a state of matter so energetic, it's literally what stars are made of. This state is called plasma, and it's wild. I want you to imagine pumping a gas with so much energy, we're talking temperatures like inside the sun, that the atoms themselves actually start to break apart. The electrons get stripped away from their atoms, creating this superheated soup of charged particles. You've got positive ions and free-floating negative electrons. This is what it means for a gas to be ionized. So what's the big difference between a regular gas and a plasma? It really comes down to one word: electricity. A normal gas made of neutral atoms doesn't conduct electricity very well at all. But plasma, since it's full of all these free-moving charged particles, is an excellent conductor of electricity. And it gets pushed around by magnetic fields in a really dramatic way.
So where can you actually find this incredible stuff? Well, the sun and every single star you see in the night sky are just giant balls of plasma. And right here on Earth, a bolt of lightning is a powerful fleeting streak of plasma. We've even figured out how to harness it in technology, like in neon signs and fluorescent lights.
And all of this leads to a pretty mind-blowing fact about our universe. See, here on Earth, we're surrounded by solids, liquids, and gases. They feel normal to us, but on a cosmic scale, they are incredibly rare. Over 99% of all the visible matter in the entire universe exists in the plasma state, which kind of makes sense when you think about it, right? The universe is mostly giant, incredibly hot stars and vast clouds of interstellar gas, environments with the insane energy needed to create and sustain plasma.
So let's just take a second and recap this whole journey. As we've seen, the great transformation between states of matter isn't about changing the substance itself. Water is still water, whether it's ice, liquid, or steam. It's all about changing the energy of its particles. This brings our journey up the ladder full circle. We started at the bottom with low-energy solids. We added some energy and got liquids. We added a lot more energy to get gases. And finally, with the absolute highest energy of all, we reached plasma. It's a clear, simple progression, all driven by energy. Okay, so why does any of this matter? Well, because understanding these states is fundamental to understanding our world. It explains everything from weather patterns and how we cook our food to complex industrial processes and even the very nature of the stars themselves. Everything around you is matter in one of these four states. And I'll leave you with this one last thought to chew on. We've just learned that plasma makes up nearly all the visible matter in the universe. So, why is it so incredibly rare here on our own planet? It's a question that really puts into perspective just how special, and maybe even how lucky, our little corner of the cosmos really is. Thanks for climbing the energy ladder with me.